Polysaccharides are polymers of glucose. Different organisms link monosaccharides together using dehydration reactions to form several different polysaccharides. The most important three are starch, glycogen, and cellulose. Let's first discuss starch. Starch is used for long-term energy storage in plants. A starch can be branched or unbranched. So in the first example here, we see unbranched, and here we see these branches coming off. Glycogen has the same kind of bond between monomers as a starch does, but glycogen is always highly branched. So you can see these branches coming off here, and there would be another one over here and back here. Okay. Glycogen is used for long-term storage in animals. It's used in muscles to provide a local supply of energy when needed. Glycogen is broken down to obtain glucose. Again, what kind of reaction is used? So if we're trying to break apart a molecule into two or several smaller pieces, we're doing the opposite of dehydration synthesis. So we're putting the water back in order to separate the molecule, and we call that hydrolysis. So hydro meaning water, lysis meaning to lyse or split the polymer. Finally, cellulose. Cellulose is a carbohydrate used to make cell walls in plants. Cellulose has a different kind of bond between the monomers, and that bond forms chains that are cross-linked by hydrogen bonds. So you can see here all of these hydrogen bonds between, okay? All those hydrogen bonds are what form that cross-linking and chains of the monomers. Because cellulose is the principal structural molecule in cell walls of plants, it needs to be strong. Animals cannot break down cellulose without the help of intestinal bacteria. Cellulose is commonly referred to as fiber. And so how do we get energy from these polysaccharides? Well, they first have to be broken down into monosaccharides, into glucose. And again, if I'm going to add water here to break this bond, I'm using water to break the bond, and we call that hydrolysis. So hydrolysis occurs breaking the polysaccharide into glucose molecules.